Well, good afternoon and welcome to what I think is probably the final session on this theatre today, the final session of NAB 2025. So thank you to the faithful friends and others that have gathered for this final presentation. This presentation is very much along the theme of much of the stuff that's been talked about today, asynchronous media exchange for live production in compute. I'm going to be giving you possibly some of the higher level context behind it. But what I would like to say is if you can see the pink booth over there that says appear, after this event, if you've got a few minutes, we can actually show you a live demo of asynchronous media interchange happening between multi-vendors on compute, which is where we're heading here. So a live demo is available. A little bit about me for those that don't know me. So I've been in the industry for a fair little while. I spent 22 years working for a service provider. Then I moved to the dark side in 2010, and I've been in vendor land for the last 15 years. First of all in Nevion, which became part of Sony, and then for the last 18 months with Appear. So some context. I think roughly speaking, we've had 100 years of television now. So we're roughly 100 years. And what I want to do is point out what we're looking at with this asynchronous thinking of live media exchange is actually a severance of a thread that's been running right through that time. Now, over those 100 years, there's been quite a lot of changes. There's been some big trends in consumption. Probably those big trends of changes in consumption have been in the last few years. Up until then, I guess there was the monochrome to color phase. Then there was the SD to HD phase. Then there was that blip of 3D and then back again, and maybe a bit of 4K but the biggest change to consumption in recent years is obviously people consuming it non-real time, consuming on other devices, not really consuming as much linear television as they used to. But we're not here to talk about the consumption side. We're here to talk about the way production is done and the technology changes and the way we can actually optimize in a workflow manner the way we do production. Now, if you can think back to the dim and distant days of COVID 5 years ago, when we wondered what on earth had happened to the planet, I did some work with a DPP group on what we call the different ways of doing production. And if you look at these diagrams, they just show you the location agnostic live production. This is not an exhaustive set of options, but the different ways production is done. So that top way at the very top, that's your traditional TV studio thinking, where your acquisition devices, your cameras and microphones, and your processing, your devices that are making the program, and your storage, and all your control is being done at the same location. There is then a whole load of other models, of which the second one was definitely a significant player during COVID, remote control. But there's these different models are evolving, and the reason that's being enabled is the IP workflows, both in the wide area network and within the facility, within studio facilities, means that it's very, very flexible to do this. And there are some of these workflow transformations are actually significant cost savers. So for instance, if you've got a team doing the productions that are centralized, and I've actually talked to several of these both in the US and in Europe in recent months, you've got teams of skilled experts that can do three shows in a day rather than one show in 3 days, which is typically what happens if you're traveling into the event. So there is some real genuine cost savings with people. There's cost savings with equipment because you can share all of those resources much more effectively rather than having to cart them all the way across site. There's also things like sustainability benefits, and not only sustainability, but accessibility benefits, because if people are working in an optimized, centralized environment, that's much easier than working in the back of a truck in a car park behind an event. So that's the context of the flexibility production, and just pay attention to the bottom one there. When I say cloud, I mean software. It could be on-prem, it could be public service, public hosted cloud. Another trend in the industry, which is really what we're heading here, is everything is moving to a more generic capability within broadcast. The IT industry is orders of magnitude bigger than we are broadcasters. We like to think we're special in broadcast, and of course we are very special. But we're moving to more and more generic stuff. So our beloved BNC and XLR connectors are gradually fading into the distance as we have Ethernet connections on everything. But that's good because we don't have to worry about eye height and all that physical layer stuff that we used to spend all of our time on, and those pathological test signals and everything else. That's the thing of the past. We're now virtualizing stuff. We're moving things from single function appliances into compute. That compute may actually be somewhere else. The dematerialization, quoting Mr. Poulon, who's somewhere around here, I think, at the moment. And networking. We traditionally have used very expensive leased lines for broadcast. Now we are actually able to use a lot more public internet connectivity. We're able to use LEO. We're able to use 5G. All of these tools which enable us to do more effective. And it's actually making program production more accessible for and more cost effective. So a key enabler here is compute is ready for live production. So as we look over the last 20 years, we've been able to do more and more stuff. Compute was fast enough to do tons of audio stuff 20, 25 years ago. And now we've got ubiquitous 100 gig low cost interfaces, NICs on compute. And this is just some example numbers here, but we can actually handle and transfer a lot of video very easily uncompressed within compute. And we're going to come back to the uncompressed. And a lot of those underlying transport tools, the inherent IT fabric, nothing special for broadcast, are really suitable now and of an age to be able to support what we want to do with compute. Now, the thing about compute, if you think back to my 100 years of television, compute doesn't work in a nice linear way like we do with television pictures and the way we do with television connectivity that we've done for the last 90 years. Everything that we've done has been what I call linear and synchronous, and I'm going to unpack that in just a minute. But computers work best if you give them a bunch of data very quickly, they do the math on it as quickly as they can, and then they shove it out again. And what we're trying to do, the sea change that we're bringing about this year, largely speaking, with all of the work that's going on, is actually saying, let's use compute natively. Let's use compute how it works best and adopt the way we actually interface in and out of it. So the next picture is one I've actually been putting up for the last 5 years in diagrams, because this attempts to show this transformation. So the acquisition on the left-hand side is always going to be a linear function. You're going to have a linear frame capture happening, linear sampling with your microphone. The consumption at the far end is always going to be linear because you're putting it back for human beings. And of course, those people involved in the production, in the gallery, those people in the sound booth, need to actually see and hear in real time. But apart from that, all of the processing in the middle, right from the camera onwards, doesn't need to be this linear propagation of data. It actually can be clumps of data, as long as, and we're going to come to this in a minute, as long as we've got the timing information propagated, so we actually know which samples to do the math on at which point, so we actually know which data is which. Another key benefit of us moving to compute in the way we do live production is a lot of the capabilities that have been the preserve of NLE and effectively post-production are now actually things that we can actually use within the live compute workflow. Compute generally does things very fast, and most functions can run faster than real time, which is great because that means as long as we architect it right, we can minimize latency. But there's a whole load of AI tools, etc., that we can actually use. And because once we've got those native media data into the compute in an accessible storage format, more of that later, we can actually then use that for a variety of tools, both the preserve of the existing live production workflow, but for other applications as well associated with auto highlights creation, etc. Okay, a bit of history for you here. So this is the start of that concept of a linear stream of data. So this is one of the very first 1930s mechanical systems that was creating television. And what we've done for 90-something years then is propagate that. So We then moved to the CRT, and we had a way of scanning through the lines, scanning the picture, and then we had that flyback arrow there, where we had what we call our vertical blanking interval, which was to give time for the electron beam to get back to the top left of the picture to start again. And actually, interestingly, we have inherited that thinking all the way through to and including ST2110, which at some point was going to be the break with the past. But actually in 2110, we still have fractional frame rate. In 2110, we still have vertical blanking interval in the way we actually do timing. So we've not necessarily, learned from the way we do that. We haven't become properly compute native. And because 2110, we spent a lot of time working on the -21 part, which was a timing specification to really, really make sure that all of those packets are nice and linear in the way they're propagated. And of course, that's not good for native compute. So what you were going to see on here, if it was going to play properly, on the left-hand side was a nice constant flow of data, a constant flow of water coming out the hose pipe. And on the right-hand side is someone putting their finger out and letting it build up, and then you burst this data out. The thing about the way we have done video and the tricks we've done with the way we've done timing with video systems has been like the one that you can't see happening on the left-hand side, because if you've got a constant flow of data, you actually don't need to worry too much about time stamping and stuff, because you know that every so often is a new frame, and I can buffer things and I can work out the relative timing because the hose pipe has a constant flow of data. Where we're getting to now is a break with that. So this asynchronicity, which is necessary to actually use compute natively, is a break with the past. So everything from, I think, 1936 through to now, we've propagated this linear thing, and now we're in a situation where we can go asynchronous. And the question is, thinking back to my picture of a couple of things ago, how far does that asynchronous sit? It needs to be asynchronous within the compute. That's what we're fundamentally saying. But actually, do we end up in a few years' time with the cameras having an asynchronous time-stamped interface on? And maybe the only point it ever gets back to a synchronous situation is when we actually play it back to the consumer on the consumer's end device. A few things for those that have come from an appliance perspective. Traditional appliances that are FPGA based typically have a very, very defined number of clock cycles in which things happen. So we have a very tight timing specification. Compute doesn't work like that. The execution time is a little bit more variable. So you have like what we're calling here a T-max, which is the concept that's the worst case time it's going to take the compute to execute that function. And then what we can do as we move through a process where we're aggregating one function, then another function, we then aggregate our T-maxes from the different functions to work out what the overall timing is going to be. And so we end up with something like this. So the purple is my linear synchronous interfacing, and then within these virtual compute functions, we've got this asynchronous handoff, which is the red arrows. And the great thing about this is, once one has finished, as soon as you've finished, and you may actually do that, maybe it's a 20 millisecond frame because we have nice frame periods in Europe. You maybe have a 20 millisecond frame period, but you actually may do the math, the compute in 2 or 3 milliseconds. And as long as your other data is available, you can then carry on. So latency optimization is something that can really be done here. But the big but, and it's something that we haven't done right in previous specifications, is we haven't had a system level thinking, and we haven't thought about propagation of timing information. So one of the things we have to get right in the work that we're doing now is to actually make sure that acquisition time, T0 on the left, is not only immutably connected to the media clumps that are generated, that bunch of audio samples or that video frame or that partial video frame. And we need to make sure that tag, that timing information tag, propagates through the whole workflow with that data. Or else, in an asynchronous world, thinking back to my hose pipe, all bets are off. Same applies, obviously, for the audio. There is a possibility that you can't timestamp it fully in some scenarios right at the device, but at least you can timestamp everything on the ingress to the compute. And then you may need to add some offsets because there may be some other latencies on some feeds coming in from a LEO feed or from a 5G feed that makes some of those feeds a bit longer in time than some others. So if you want to look back at some of the other presentations that have been done this morning online, I can recommend several of them because they've been expertly talking about things, but I just want to highlight a few things that have been happening in the industry. This is the DMF, a very brief summary of what the DMF are looking at in terms of the layering of the architecture, and we're looking very specifically at this media exchange layer. I recommend you read their paper that they published last autumn on this. What we're looking for here is an abstraction point, an API, a way of handing data off that's completely agnostic to the physical platform you're on. So it's very, very important that we're not platform dependent here. So all of the work here is a platform agnostic thinking. Now, there's been some work happening in the last couple of years on this already. The Video Services Forum have had something called ground to cloud to cloud to ground, and try saying that when you're tired. And the cloud to cloud bit has been defining an asynchronous API where we can actually hand this data off. That was effectively published in its very first draft this time last year. Several people have been adopting it, and we can do a demo of that on our booth afterwards if you'd like to come along. And basically that's doing this. That's giving you this asynchronous interconnect. And it's something that we've learned along the way, and over the last year we've been optimizing that. So several entities have been doing stuff. So this is a very, very brief summary of, it's not an exhaustive list, but this is just some people that have been playing with this. So we've in Appear with what we call our media transport bus. VSF have been talking about GCCG. Frame, other people we've been working with and prototyping with in the UK have got what they call their virtual digital interconnect. They're all very, very similar, and actually we've done some shimming between these to get these asynchronous interfaces. And the EBU MXL, which has really come into life in the last 3 months, is actually very, very similar. We're kind of 95% aligned. And one of the things we've been doing in the background at the conference here is actually talking about how we make sure in the next 3 months we get full convergence of these approaches, so we only have a single uniform approach. All the fundamentals on the right-hand side, which I'm not going to unpack, are there. It's also worth saying there's another initiative, because there's some thinking when you actually look at the way the workflow and compute works. There are two methods of thinking. The traditional one, which is what you need for lowest latency in a live production workflow, is a signal-centric architecture. I've done one thing, I push it into some memory, do the next thing, push it on, and so on. The storage-centric architecture, if you want to think back at what I was talking about, the NLE functions, the typical post-production functions where you want to access all of those media files and do stuff with them that's not part of just the live production workflow, but we want to do things in parallel. Then once you've got a storage-centric architecture, and I recommend you look at the BBC's work on TAMS, because they've done a very, very straightforward solution there proposed, which allows you to actually do this very thing. So this synergistically lines up with what we're talking here. Latency, just want to talk, I've got 45 seconds, so I'm going to talk very briefly. Latency optimization is really, really important, and we have an opportunity, if we do this properly, to actually make sure we minimize latency. I also want to just say security is very important. Security is always important in traditional media exchange, but when you're actually sharing memory buffers within compute between vendors, the security of the way that's done is really, really important. This is a very, very brief summary of the demo which we're doing. The two vertical red blobs are the asynchronous interface points between our Appear VX solution going into Frame solution, going back into an Appear solution. And we can show you that working 16-bit planar asynchronous 1080p video. So I'm really hoping that this year is going to be the year for real consensus and action, and we can actually really, as an industry, come together to make sure we have a fully agreed way forward on doing asynchronous media exchange. So the end content producers across the world have the ability to do best of breed functions within a software ecosystem and actually produce efficiently for the future. So do come over to the West Hall. It's W2042. The Appear stand, and as always at the end of my presentations, I'd like to invite you either over there or if you're in the UK to come and join me for a nice cup of tea. Thank you for your time at NAB.